So, we are doing a review on probability. These are various things that you might have done in year 10. So you have the outcomes, which are all the possible things you can get from a trial. You have sample space, which are all the outcomes. Probability of something happening is the number of outcomes that you have for event A over the total sample space, total number of sample space. You have the probability should always be between 0 and 1, and complementary events are anything that's not the event. So it's always 1 minus the probability of the event. This is a Venn diagram, and you need to make sure that you know the Venn diagram well. Now, specifically in a Venn diagram, you always have two main things that you have to worry about. One of them is union, one of them is intersection. Union and intersection are the two main things you need to be able to draw on a Venn diagram and also identify. So, if we were looking at A intersection B, that would be the center of the circles. If you had A union B, that would be everything in A and everything in B that we're looking at. Now, this symbol here shows you the total sample space. It's called psi. You can either use psi or you can use epsilon. Both of these are acceptable. It's up to you which one you want to choose. With mutually exclusive events, we would actually have two separate circles. So, do the total sample space. Then mutually exclusive means if one event happens, the other cannot happen. So let's say if you're rolling a die, you can roll a 2 or you can roll a 3 in one die roll, but you can't roll both. They would be mutually exclusive. So also remember, because they don't intersect, the probability of you having the intersection is going to be 0. The addition formula. The addition formula shows us how A union B is related to all the other ones. So if you have a look at the diagrams above, if you add A and B together, we would actually double up on the section in the middle, which is A intersection B. So in order for us to find A union B, we would actually have to subtract A intersection B. Now just remember, when you are doing this, we will not tell you when you need to use this. You need to be able to identify when this would be necessary. So the general scenario is you'll be given 3 of these and you'll need to find the other. It can be any of them. Just make sure that you know which one, how to write the formula out and how to rearrange it. The probability table shows us all the different probabilities, and it shows us all the different intersections. So let's start off with the basics. They all have to add up to 1, and if you have the probability of B and B dash, you have to make sure that they add up to 1. Same with A and A complement. Now wherever they cross over, that will be the intersection. So this will be probability of A intersection B. This will be A complement intersection B. This will be A intersection B complement. And this will be the complement of the two intersecting. We also have a lattice diagram on the right. Remember, this shows all the possible outcomes. Now, when you're looking at all the possible outcomes, you need to list them all out, and then by doing this will help you find various things. So for example, if we're looking at this 2 dice roll, so see how it says first roll and second roll. If we're looking at the 2 dice roll and we want to find where all the numbers are the same, you can just simply highlight it on the diagram and see that we have 6 out of these 36 possibilities, or 1 out of 6 for that to happen. Conditional probability, remember it's kind of like dividing. It's not actually dividing, but just remember it's kind of like dividing. Your probability of B for the last one there. So when you're reading this, that's the probability of A given B. So you're trying to find all the possibilities given that B's happened. If we were to do the reverse, probability of B given A, you would then find the probability of B intersection A over the probability of A. Now, just remember that the probability of A intersection B is the same as the probability of B intersection A. So you can interchange these two around. Independent events. So these are for events where both of these can happen, but one has no effect on the other. So for example, if we're looking at coin toss, the coin toss and a dice roll, or die roll. One will have no effect on the other. They're both independent events, and we can simply multiply to find the probability of both of them happening. We can also do the same for something that has that says with replacement. So whenever it says with replacement, you can just simply multiply both the probabilities of both of them happening. So for example, if you have a drawer and you want to pull out 2 socks, 2 green socks or whatever, or blue I guess, seeing as I drew it in blue. If you want to draw 2 blue socks with replacement, then you would say this is 1 out of whatever it is times 1 out of whatever this is. Okay? Maybe I should just write that. Alright, so just to give you a couple of hints, it's nothing that we haven't looked at yet. Whenever you're doing a probability question, the first thing you should probably look at is drawing a Venn diagram. The reason for drawing a Venn diagram is so that you can see what the situation's like, and if you have any intersections, if you have any unions, you can actually physically see what it is, and you can use that to find anything that you're missing. The second big hint I have is if you have a lot of intersections, then write a probability table. Because by doing that, then it shows you all the different intersections and how they relate to all the other probabilities. So, as I was saying before, do that first, draw a Venn diagram, and then if there are lots of intersections, draw out a probability table. Alright, counting techniques. So, box tables, remember you just draw out the boxes, showing all the different things happening. So for example, if you have license plates where you have 3 letters and 3 numbers, you would do 26 letters on each and 10 numbers on each one. Once you've done that, then you just write out all the possibilities by multiplying them. Finding out the number of ways to arrange them by multiplying them, and then you find out what it is. Factorial. So remember, if you have a factorial, you keep multiplying until you get a 1. So 3 factorial, for example, would be 3 times 2 times 1. Arrangements in a circle. So remember, arrangements in a circle means you are sitting around in a round table, so you would have to actually divide how many spots there are. That's why it always becomes n minus 1 factorial. If you're still not sure, the other way of writing it out is n factorial over n being how many spots you have, because you can arrange them in n different ways. So for example, you had 5 spots, you can rotate it 5 times and it's still the same. So you would do n factorial over n, thus giving you n minus 1 factorial. If you're doing arrangements in a group, so for example, if we're looking at the word Tatooine, we can see that the letter T is repeated 3 times. So we have a total of 8 letters. That gives us 8 different possibilities to arrange the word Tatooine, not all the letters in there. And because the T is repeated 3 times, we would have to divide it by 3 factorial. Because we have a group of 3 letters, and we're going to divide it. If you're still not sure, you can swap the T's around and they're still the same. That's the reason why. Combinations and permutations. Now, you need to make sure that you can write this out by hand, and also work it out by hand and by CAS. So NPR, you would do n factorial over n minus r factorial. If you have combinations, it will be n factorial over n minus r factorial r factorial. Now, if you're not sure when to use each one, look for these words in a question. For permutations, you will have arrangements. And for combinations, you would have generally committee. It doesn't always have to be these, but these are really big hints as to which ones you need to use. So look for those words and that should help you. One more thing with combinations. The other way to write it out is putting it inside a bracket. You write n on the top and r on the bottom. So hints for doing these questions. Best hint I can give you is draw a diagram. If you draw a diagram and you can see this visually, it'll make everything a lot easier. You'll be able to see it a lot easier and you'll be able to work it out a lot easier. Whether or not you need to draw it as a box plot, whether or not you need to draw it in a circle, in a group, you need to write them out so that you can see it. So I'll give you an example. If you're looking at, say you have a bookshelf like this, and you have 7 books in total, and 2 of them need to be grouped together. Because there are 7 books and 2 of them need to be grouped together, 2 of them will essentially take up 1 slot because they're going to be put together. Then you have an extra 5 slots left. So 1, 2, 3, 4, 5. Now, effectively, when we're working this out, we can now see that we have 6 slots, essentially. Okay, so that'll give us 6 factorial. Then inside here, we have 2 books, and that bit gives us 2 factorial, because we can swap the books around. Binomial distribution, you need to make sure that you can write out the equation, and you also need to make sure that you can work it out in your CAS. Just a reminder, to find this on the Casio, you will go under interactive, then distributions, then you will look at discrete. Now, if you don't quite remember what each thing is for, P is for probability of success. Okay, so let's say you're looking at a dice roll of obtaining 1, that'll be 1 out of 6. And the other part 1 minus p is where you define any that don't work. X is how many outcomes you want, and n is the total number of outcomes. So I've listed them out here like so.